Step 1. Testing and adjusting the pointer. Testing and adjusting the pointer is necessary for the accuracy of value reading of the multitester. In order to do that, first, you need to select a level of resistance by rotating the range selector knob going to your desired resistance level. Slowly turn the knob clockwise to your chosen resistance multiplier. In my case, I choose to set my resistance level into times 100 ohms. After setting the resistance, you can now get your test probes, then put it together. As you can see, the pointer of your multitester will move once you put your test probe together. If your multitester is accurately set, the pointer will land on the 0 ohm. But there are some instances that the pointer lands in different scale, as seen in the figure. In order to zero in the pointer, you can use the 0 ohm adjustment knob. Rotate it clockwise or counterclockwise depending on the problem you have encountered with the pointer. In my case, I will rotate it clockwise. So now, as you can see, our pointer is already in the 0 ohm and our multitester is ready to use. Set the range selector to the appropriate resistance scale. For this step, I have here an example resistor and the resistor color coding chart. We will find the value of this resistor using a resistor color coding chart. If we decode this one, it will be first band is red, which is equivalent to 2. Second band is black, which is equivalent to 0. Multiplier is brown, which is equivalent to times 10 ohms. Therefore, 2, 0 multiplied by 10 ohms, the value of this resistor is equals to 200 ohms. Using this result, we will set our multitester range selector according to the multiplier of this resistor. It will be times 10 ohm. We will now turn our selector knob clockwise to set our multitester into times 10 ohms. Now, our multitester is ready for testing resistor. Step 3. Place the test probes on both ends of the resistor. In placing the test probes on both ends of resistor, you can put the positive or the negative probe in either left or right of the lead, because resistors has no polarity. You can now put the positive and negative probes of multitester to the left and right leads of the resistor. Step number 4. Read the result of scale, then multiply it with the resistance. In reading resistance, get the value of scale of which the pointer lands. In this example, the pointer lands in 20 ohms. After getting the value of resistance in the multitester, we will now multiply it with the range selector value. If we apply the rule to get the value of the resistor, it will be scale reading multiplied by the range selection is equals to the value of the resistor. Therefore, 20 ohms multiplied by 10 ohms is equals to 200 ohms. The value of this resistor is 200 ohms. If the pointer lands on an unlabeled scale, you can use the table of division of ohms. Example: in this figure, the pointer lands in the unlabeled resistor scale. If this will happen, you can use the division table of ohm scale. First thing to do is to figure out on which bracket of major division does the pointer landed. In our example, it is between 3 to 10. After analyzing the major division, find the equivalent value of each line in the table. Since it is in bracket 3 to 10, each line will be counted as 0.5. If we count each line with the value of 0.5, therefore, starting from 3, it will be followed by 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5, and 8. As we can see, our pointer landed on the value 8 of the resistance scale. After getting the value of resistance in the multitester, we will now multiply it with the range selector value. If we apply the rule to get the value of the resistor, it will be scale reading multiplied by range selection is equals to the value of the resistor. Therefore, 8 ohms times 10 ohms is equals to 80 ohms. The value of this resistor is 80 ohms.